Hi, this is Algebra 1, Module 6, Lesson 3, Scott's Macho March. So, Scott was determined to eat right and get in shape. He joined a gym and added push ups to his daily exercise routine. He started keeping track of the number of push ups he completed each day in the bar graph below, with one day showing he completed 3 push ups. Excuse me. After 4 days, Scott was certain he could continue this pattern of increasing the number of push ups for at least a few months. Model the number of push ups Scott will complete on any given day, include both explicit and recursive. So if we look at this, day 1 is 3, 2 is 5, 3 is 7, 4 is 9. So if we do our, actually, no, I'm going to do this a little lower for a reason here in a minute. I'm going to actually write this table down here because we're going to add to it for our next bunch. So here we have day. And so day 1, he did made push-ups. He did 3. Day 2, he did 5. Day 3, he did 7. Day 4, he did 9. I'm going to guess on day 5, he did 11. So on day N, what are we noticing? Well, it's a +2. Erase those marks. We notice up here, it is a +2 each time, right? So it must be linear. So I'm going to put up here, he starts with 3, and then he adds 2, but it's not, it's after the first term for his equation there. So when we do our, here, we're going to do f of 1 is 3, f of n then is f of n minus 1, the previous, plus 2, right? Which means our explicit is going to be we started with 3, and then he adds 2 after the first one. So there's our explicit. That's the linear. That's what we're used to. We got that one down. All right. I'm going to make that a little nicer. Okay, next. Scott's gym is sponsoring a macho march promotion. The goal of Macho March is to raise money for charity by doing push-ups. Scott has decided to participate and has sponsors that will donate money to the charity if he can do a total of at least 500 push-ups, and they will donate an additional $10 for every 100 push-ups he can do beyond that. So now Scott is going to track the total number of push-ups done to any given day of the month. So he has got some uh, he let's see. Yeah. So if he's looking at total, then what do you think? If we're going 2 each day, doing all this one really, you're just estimating. So I don't know if he does um, adds 2 to every day, but he's still doing all the other ones. I don't know. What do you think? Like 500? Will he hit that 500? We'll go ahead and he'll say, we'll do that 500 push-ups. He'll make it. So draw a diagram that shows the total number of push-ups he's done in a month at the end of each day. So uh, we are going to basically just get going with the pictures of the first one. So we know day 1, he's done 3, right? But at the end of day 2, he's done the 3 from the first day plus the next ones, right? Yeah, total number. So the total number by day 2 is day 2's plus day 1's. And then for day 3, what did we say he had on there? It was 7. Get 7 marks on here. 1, 2, 3, 4, 6, 7, 2, 3, 4. Okay, that's 7. And so then we still have the 5 from day 2 and the 3 from day 1. So we're looking at a total of there. And so 4, oh boy, he had 9, right? So 1, 2, 3, 8. And then so he's going to have 7 for the next one. And then he's going to have 5 from the other day, and then 3. So they're piling up pretty quick. So let's see how many he's done after a week. So if you're looking at our table here, we're going to add another column that says month total. So here he did 3, but he did the 3 plus the 5, so now he's looking at 8, and the 8 plus the 7, so now he's at 15. 15 plus the 9, so now he's at 24. 24 plus 11 is at 35. So if we kept going and had 6 was 13, 7 was 15, it'd be 35 plus 13 is 48. 48 plus 15 is 63. So at the end of the week, go back down, you'll have done 63 push-ups. So that's using a recursive formula, right? We kind of just kept going with our pattern on that. So if I were to do the recursive, f of 1 was 3, but then f of n equaled 2. So the original one was 2n plus 1, right? But then we're going to add that to his previous f of n minus 1. Because whatever he did the first time, 3, we've got to add to it that term numbers, that linear pattern, right? Let's get up here. That's what he had. He starts with 3, but we have to add that each time. So how are we going to figure that out? What we're doing to go from basically 5 to 35, 4 to 24, 3 to 15. Now, we know there's got to be some sort of square in there, right? Because this is quadratic. So if I just start with 1 squared plus what equals 3? Well, 1 squared is 1. 1 plus 2 equals 3, right? And if I say 2 squared plus something equals 8, well, 4 plus 4 equals 8. 3 squared plus something equals 15. 3 squared is 9. 9 plus 6 equals 15. I'm going to do a couple more here and see if we can see a pattern. 4 squared plus what equals 24? Well, 16. 16 plus 8 is 24. 5 squared plus what equals 35? Well, 25 plus 10 equals 35. So think about what is the commonality between this number and this number, this number and this number, this number and this number. Well, 2 is twice as much as 1. 4 is twice as much as 2. 6 is twice as much as 3. 8 is twice as much as 4. 10 is twice as much as 5. So I'm essentially doing my step squared plus twice my step to get my number, right? I'm squaring that, and then I have to double it to get what it is. So n squared plus 2n gets me my monthly total. So that's what I'm going to put down here. F of n equals n squared plus 2n on here. So will Scott meet his goal and earn the donation for charity? Will he get the bonus? And how much will he get? Well, there's 31 days in March. So if I go f of 31, then I'm doing 31 squared plus 2 times 31. Well, 31 squared, 31 times 31 is 961 plus this one is 62. So 961 plus 62 is 1023. So what he'll get how much? See how much does he get? They will do at least 500. They'll donate an additional 50, or sorry, 10 for every 100 he can do beyond that. So they're assuming he's got to do 500 first. So if we take out the 500, then that's 523, which you divide by 100, he'll get 5 times 10. So he'll get $50 from his sponsors. So yes, he will reach his goal and he'll earn $50 for his additional push-ups. So that's other ways to figure out how to come up with your quadratic equation on there. Thanks for joining us, and we'll see you next time.